when we are eating carbohydrates and more than we can burn, of course blood sugar goes up, insulin goes up, and we store sugar as fat. The next hormone that I wanted to talk about is called leptin. So fat cells secrete leptin. And we used to think that fat just sat there and really did nothing. But now we know that fat actually secretes several different kinds of hormones. And hormones are communicators. So fat is actually trying to communicate with us. Fat cells can also secrete estrogen. And so the more fat cells that we make, the more estrogenic that we can become. And this has implications for even cancer. So hormonal cancer, breast cancer, prostate cancer, but it can also throw the hormonal balance out of whack if we become what's called estrogen dominant, meaning that we have too high of estrogen in relationship to progesterone or other hormones. So as soon as we store sugar as fat, this fat cell makes leptin, and leptin travels to the brain, and it tells the brain, I just ate more sugar or fuel than I can burn at this particular time, so I'm going to store extra for later. Stop the appetite. So it's a feedback mechanism to tell the person, don't need to eat anymore, we have enough. So it's a great feedback mechanism when it's working correctly. But in the scenario that I was talking about earlier, if we're eating some carbohydrates, and I don't mean a lot, just some carbohydrates throughout the day, more than we can actually burn, our blood sugar is up, our insulin stays up all day long, and so we end up storing a little bit of sugar as fat all throughout the day, and then leptin gets made every time after every meal. And so pretty soon leptin also has a long half-life, so it can stay high in the blood for hours after it's secreted. So what ends up happening is leptin just starts to float around high, just like insulin does. And so if we have leptin floating around all the time, all through the day, the brain stops hearing the message of leptin. It's kind of like if we sat in a room and it smelled like trash, we would smell it strongly, but if we stayed there long enough, we would tend to stop smelling it so much because our sense receptors in our nose become resistant to the smell. So it's kind of like the same thing for the brain. If leptin is always there, the brain can't smell it anymore. It can't notice that it's there. It becomes resistant to the message of leptin. And if it thinks that leptin isn't there, then we must not have any fat. And if we don't have any fat, it's an emergency. And so it turns on our hunger center and makes us want to eat. And usually what it makes us want to eat is carbohydrates, because those are immediate fuel, and it will give us fuel quick. So what do you do to get your insulin and leptin levels down? If you want to go for it, you eat protein, some good fat, and some fibrous carbohydrates. Fibrous meaning most of the vegetables minus a few of the sugary or starchy ones. So if you're eating that all throughout the day, you're not going to be triggering a strong insulin response. So insulin starts to come down, and then eventually when the insulin and leptin come down, the body says, oh, I have fuel here that I can burn. So the appetite shifts because we can start burning the fat that's on our body, and we don't need to eat to get our fuel.